Weirdest traits we lost through evolution. Did you know that we once had a tail, or that our distant ancestors could see in the dark? Evolution has shaped us in some truly bizarre ways, and in this video, we're diving into the weirdest traits that we've lost over time. From the vestigial organs we don't even think about, to the strange abilities our ancient relatives had. This is the story of how our bodies are packed with clues to prehistoric traits that we have lost over time. To begin with, let's look at a trait that we haven't so much lost as lost sight of over the years. In the 17th century, the foundation of much of modern science was being constructed by one of the greatest minds of a generation. Isaac Newton wasn't just smart, he was wise. In a letter to his rival, Robert Hooke, he wrote the notorious phrase, "If I have seen further than others, it is by standing upon the shoulders of giants." This was as much of a put-down of his competitor as it was a declaration of humility, as Hooke was substantially shorter than Newton, and the pair were bitter rivals. But that's another story. But before we go backwards, let's go forwards. Physicists such as Christian Doppler gave new effect to Newton's work, and while teaching at the University of Vienna, then passed on ripples of this to an Austrian pea fanatic called Gregor Mendel, helping him develop inheritance patterns in plants. In turn, it would be giants like Mendel upon shoulders William Bateson stood when he discovered Hox genes. Bateson translated Mendel's work into English and worked to reinforce the concepts of Mendelian inheritance by combining it with the ideas of evolution from yet another giant, Charles Darwin. Bateson is the reason we use the word genetics, let alone study it as a discipline, and it is through genetics, and Hox genes specifically, that we can see farther into the world of evolution than Newton would have been able to conceive. Our evolution is the story of such giants, dating back almost 4 billion years, to the first single-celled life forms, not least that first intrepid fish that took steps out of the water to become the earliest land vertebrate. Since then, our ancestors have gained and lost many traits through a process of great trial and error, and thanks to our modern understanding of genetics, we can see many of the traits that we once had. But more excitingly, we are coming close to learning how to get them back. Vestigial organs, being remnants of structures that were once useful to an organism's ancestors, but have become non-functional or have a reduced function in the current species, had been recognized by giants as far back as Aristotle, but Darwin may have been the first to identify them as evidence for human evolution, which he described in his magnum opus, On the Origin of Species, and then expanded upon in The Descent of Man. And it's here we find the first item on our list. Nictitating membranes. Many animals have a sort of third eyelid. No, not like that one that opens when you've had a heroic dose of mushrooms, but one that stretches damply across the eyeball, under the outer two. This third eyelid serves several purposes. When we open our eyes underwater, the image is blurry, but like our diving masks, this so-called nictitating membrane allows some animals to see clearly underwater. In birds, it's useful as biker goggles to keep the wind out of their eyes, and in other animals, it can be handy for protecting eyes against lunging at tourists exposed to powerful UV rays, or desert dust. In primates like us, they range in effectiveness from the full coverage of the membrane in podos to roughly 10% coverage in gorillas. In chimps, there is a tiny remnant of this membrane that appears to be vestigial, and in humans, it's almost entirely disappeared, except for a tiny flap-nosed Pleca semilunaris. But why don't we have it now? Our smaller irises, larger eye whites, and relatively high use of eye contact between humans all help humans understand what each other is thinking, and this could have contributed to more complex societies we form when compared to our closest relatives. If this is the case, we may have sacrificed eyeball protection for the ability to relay clearer, non-verbal information between ourselves. Of course, since we're all communicating with text and emojis today, we should expect the nictitating membrane to come back any time now. This is a good example of how vestiges are often flaps of tissue or lumps of organs that once did something, but now just hang there impotently like a forgotten American president waiting for a phone call. But even Darwin recognized that sometimes they can even serve new purposes, even while their original role becomes redundant. This is how our gills became ears. Our pharyngeal gills, to be precise. The story of our infinite tower of giants continues with a German embryologist called Martin Heinrich Rathke, who, in the 1820s, noticed that mammalian embryos appeared to develop gill structures early in their development. A decade later, standing on Rathke's shoulders, Carl Bogislaus Reichardt then figured out that these structures eventually develop into the mammalian ear ossicles and jawbones as the embryo grows in the womb. This shows up around the 4th week of gestation as small ridges or arches on either side of the neck. Over a short time frame, they lose their gill-like appearance and slowly become integrated into the permanent facial, jaw, throat, and ear regions. But for a brief moment, our bodies all resemble our ancestors from 250 million years ago. But how does the embryo know to form these structures in the first place, and then repurpose them into ear and jaw structures? Remember Bateson's discovery? Hox genes were so revelatory because they were found to be responsible for the where and when of body planning and embryonic development. By switching specific genes on or off along the head-to-tail axis, Hox genes orchestrate how each segment of our embryo grows and what it becomes. These same genetic commands once helped our fish-like ancestors build real gills. In modern humans, they've been repurposed to form our facial bones and parts of the ear. Neat. Excluding some statistical outliers, it's likely you and fruit flies both like fermented beverages, chocolate, and mating. But you have a lot more in common too. Both humans and fruit flies, and everything between, are mapped out by these same genes, all the way down to our tails. Yep, we're talking about tails. We're typically born with 29 very handy vertebrate and a handful of useless ones. Those last 4 or so bones are mostly fused and are another of Darwin's recognized vestiges, a tailbone. They're another little clue to our prehistoric ancestry, and while they are subtle by the time of birth, they're a lot more glaring in the womb. Much like the pharyngeal gills we see in early human embryos, our long-lost traits show up in our early form. From around the 4th to the 6th week, our bodies have 10 to 12 more vertebrae than we end up with as babies. Again, we have Hox genes to thank for this. Not only do they tell you where your tail should go, but also how long it should be. And left to their own devices, they would provide you with a nice, long, furry tail that would be great for use for balance as you jump from branch to branch. But since we apes haven't been doing that sort of thing for 25 million years, it's very fortunate that there are other genes at play to override the nostalgic approach to our Hox genes. Thanks to the very sturdy shoulders of Bateson and Mendel, a geneticist named Edward B. Lewis was able to discover that genes appear to layer on top of one another, mediating each other's effects by switching selections on and off. Lewis discovered that Bateson's Hox genes do even more than Mendel described. They move down our family line, turning off or on precise arrangements to change our shapes entirely. So, far from losing the blueprints that once told our ancestors to build gills at the front and tails at the back, we still have them in our DNA. They're just covered in coffee spills and hasty annotations to restrict their full potential, resulting in only what's necessary to make us, us. It's not clear exactly what mediates the tail reduction in the womb, but something puts a stop to it at around 6 to 8 weeks of development, layering the updated blueprint over the original to leave us with a useless nub that's no use for tree swinging at all. But Newton's knees must have been wobbling like crazy because he's now holding up 350 years of researchers, including those working on how our tails disappear in the womb, and why, sometimes, it doesn't. While pseudotails are benign skin tags or other cutaneous protrusions that have nothing to do with tails, there are cases of babies sporting true tails, and these are complete with muscles, nerves, and even in one case, bones. For better or worse, these tails are routinely removed from babies, which is probably better for their self-esteem down the line. But you can't help but wondering, what if? Another lost trait that really should make a comeback involves everyone's favorite topic and the leading cause of planetary violence across the galaxy: nipples. Humans are weird about nipples in a bunch of ways. Generally, we have 2 each, one on each side. This is, strangely, irrespective of whether you're male or female, as the latter is the only sex for which they're useful. And despite this, they're the only ones that get you banned from social media. But as mammals, we're a bit unusual even in how many we have. Pigs have 18 nipples, as you would hope to if you were giving birth to 12 or so babies at once. Dogs have between 6 and 10, sometimes even 7 or 9, which makes them quite unusual too. Cows have 4 big ones that not only don't get you banned from social media, but get an entire global industry dedicated to tugging on them. And platypuses really don't have nipples at all. They just sort of secrete milk from the glands in their armpits. With all that out of the way, it might not be so weird to hear that 1 in 25 individuals are born with an extra one. As you might have guessed by now, These are a product of mistaken genetic regulation in the womb, which means that we are all supposed to have had more nipples at some point down the line. But now, there's an inhibitor in our genes that just limits the majority of us to a boring pair. Some pairs more boring than others, of course. So, somewhere down the line of our evolution and borification, we've lost inbuilt eye protection, the ability to breathe underwater, and extra nipples. It's a wonder there's anything interesting left of us. But it doesn't stop there. The counterpart to the nipple is the mouth, and in it, we see remnants of a forgotten past too. Next, we're talking teeth. In the 1300s, Europe lost up to 50% of its inhabitants to the Black Death, bubonic plague. A little later, in the 1600s, it was back again, responsible for around 15% of London's inhabitants kicking the bucket. Because of all the death, bills of morality became a permanent fixture in London around this time, and these make for astounding reading, not just for the comical died from lethargy or piles, but because these documents are a fascinating insight into not only what killed people back then, but just how little was understood or treatable. In the year 1632, just 11 years before Isaac Newton was born, the bills of morality reported 8 deaths from the plague, 46 deaths from several accidents, 98 from rising of the lights, and 470 deaths from teeth. And throughout the century, teeth showed up as a 5th and 6th high-ranking cause of death, always after infant mortality, which was, at the time, in the thousands. So, what's going on with all these teeth? As our food got softer and our vocal language evolved, mouths got smaller and tongues got bigger. Wisdom teeth, once useful for chewing on bark and other roughage from the hunter-gatherer years, became redundant. But not all wisdom got the message. While in some folks they never show up, in others they show up partially, in others still, like the 470 Londoners in 1632, they show up with a vengeance. Impacted wisdom teeth, combined with terrible dental hygiene and dentistry as delicate as a ball-peen hammer, meant that infected teeth could go entirely untreated, until those nasty little anaerobics in the mouth made it into the bloodstream, and Londoners would quickly wake up dead. So, wisdom teeth are on their way out as we speak, quite literally, and thanks to modern medicine, we can now catch these pesky infections before they kill us. But modern medicine has at least one more nut to crack, regarding our lost traits. Regeneration. Pluck a leaf from a tree and it'll grow back. Pluck a tail from a gecko, and while you will hopefully be ostracized by all your friends, it too will reappear over a few weeks. But pluck a body part from a human and, unless it's a chunk of liver, it'll be gone forever. But why? Regeneration is why. And as we reach the highest of shoulders and the most cutting edge of modern science, we're starting to understand how useful it can be. Building upon the works of Lewis, we can now ask if we still have the gene for regrowing limbs, and even more, could we turn it back on? Regenerative medicine is the final frontier of curative medicines, and would mean that rather than scar tissue, hearts could regrow vascularity after cardiac arrest. Rather than prosthetics, patients could regrow limbs after amputation, and of course, amputation could be avoided entirely in cases where the body could rewire its nerves, muscles, and blood vessels. Regrowing limbs is part of our lost heritage, and there are a lot of other people appealing to science to get it back. But an even older giant than Newton, Aesop reminds us, be careful what you wish for, lest it come true. Evolution doesn't lose advantageous traits for funsies. There are always a reason why something is or isn't, and when something as incredible as regeneration has been abandoned, there will have been a good reason for it. Let's hope we don't find out the hard way what that reason was. So, next time you experience toothache, conjunctivitis, or discover that the thing you thought was a mole is actually an unexpected extra nipple, spare a thought for the billions of prehistoric giants to whom these once belonged. That's all for today, fossil heads. If you want more evolutionary weirdness and deep dives into our prehistoric past, check out our other videos. And as always, stay curious, fossil files. Just don't try to bring back the tail, okay? We've moved on.